Hello and welcome to The Explainer. We're going to talk about one of those things you see every single day, but probably don't think twice about, the light bulb. But packed inside that little glass sphere is an absolutely incredible story of science, of struggle, and of pure genius. So let's just start with the question that drove inventors crazy for centuries. Think about it. How do you trap lightning in a glass bubble? It sounds like something straight out of a myth, right? But this was the actual, very real challenge. How do you tame the raw power of electricity and make it a safe, controllable, and long-lasting light?
And before we get to how they solved it, you have to understand the world they were living in. For all of human history, our only weapon against the dark was fire. And let's be honest, it was a pretty terrible weapon. It was smoky, it was dangerous, and it was pretty weak. The dream wasn't just to get more light, it was to find a completely new kind of light.
So let's start right there. Let's really try to imagine what it was like to live in a world that just shut down every single night.
You really have to let that sink in. The sunset wasn't just a pretty view. It was a hard stop. It was the end of the workday, the end of social life. It was a limit on safety, on progress, on everything. Entire cities basically went to sleep, not because they wanted to, but because darkness put a curfew on human potential itself.
So, the journey to conquer the night. Well, it didn't start with a light bulb at all. Nope. It started way earlier, with the quest to understand this mysterious, invisible, and powerful force of nature. And this is what it all boils down to. Electricity isn't some kind of magic. It's just the controlled movement of these tiny particles called electrons. Once scientists figured out how to get them moving, then they could start thinking about how to turn that movement into something useful.
And here are the first two giant leaps. In 1800, Volta's battery, the first battery really, gave us a reliable flow of electricity. It was like creating a river of electrons you could turn on and off. Then, just 2 years later, a guy named Humphrey Davy sent that river through a thin strip of platinum and created the very first man-made electric globe.
And the principle he discovered is called incandescence. It's just a fancy word for something glowing because it's super hot. So Davy proved it could be done, but in that same moment, he discovered the big fatal flaw. His platinum strip just, poof, burned out almost instantly. He had the glow, but he couldn't make it last.
And that single problem, that burnout problem, became the central challenge for an entire generation of inventors. It wasn't just one problem either. It was this really complex puzzle with a bunch of interlocking pieces.
This was the question that kept everyone up at night. How do you get something hot enough to shine brightly, but somehow stop it from destroying itself in the process? It really seemed impossible. And it turns out the solution had three parts. First, you needed the perfect material, something that would fight the electricity passing through it, which is what creates all that heat. Second, you had to get rid of the oxygen, because oxygen is what makes things burn up. And third, you needed to put the whole thing in a stable, sealed container to keep it all together.
Now, a lot of people tried to solve this puzzle, but it was Thomas Edison who finally, piece by piece, put it all together. He didn't just invent a light bulb. He created a practical, commercial lighting system that could actually work. So let's break down how he did it. Edison's genius wasn't some single eureka moment. It was about perfecting three critical parts that all had to work together perfectly. First up, the heart of the bulb, the filament. After testing literally thousands of materials, Edison's team found that a tiny thread of carbonized bamboo could glow for an incredible 1,200 hours. That was the breakthrough. Today, of course, we use tungsten, a metal that can get white hot over 3,000 degrees Celsius without melting. Okay, next he had to solve the oxygen problem, and the solution was just brilliant. He used a pump to suck all the air out of the glass bulb, creating a vacuum. With no oxygen, there was nothing to burn the filament. It's that simple. Later on, other inventors improved this by filling the bulb with a special gas, like argon, which protects the filament even better and makes the bulb last longer.
And finally, there's the glass bulb itself. We don't think about it much, but it's the silent hero here. It has to be transparent so light can get out, it has to handle all that heat, and it has to maintain that perfect airtight seal. It's the little house that keeps the whole system safe.
So here's how it all comes together. 1. Electricity flows into the filament. 2. The filament fights back, creating crazy amounts of heat. 3. That heat makes the atoms shake so much they literally throw off particles of light, called photons. 4. The light shines out. But pay very close attention to that last step. Most of the energy is just wasted as heat.
And that one big flaw,
All that wasted heat didn't stop the light bulb from changing the world, but it did set the stage for the next 100 years of innovation in lighting.
Here's the number that really defined the incandescent bulb's biggest weakness. Only about 10% of the electricity it uses actually becomes light. The other 90%? Just heat. Think about it. It's basically a tiny space heater that just happens to glow.
And this chart just makes it so obvious. Look at the difference between Edison's bulb and a modern LED. We've completely flipped the ratio on its head, going from 90% wasted energy to 90% useful light. That is an unbelievable improvement.
And you can see that relentless push for efficiency right here on this timeline. Since 1879, we've gone from just heating up a wire to exciting a gas inside fluorescent bulbs, and now to the totally different science behind LEDs.
When you get right down to it, the story of the light bulb is about so much more than just technology. It's this powerful reminder that when we take the time to deeply understand the laws of nature, we can solve problems that have been with us for our entire existence.
So, the story that started with trying to trap lightning in a bottle really leaves us with a much bigger question for today. We conquered the darkness of the night. So what other huge, seemingly impossible challenge are we going to engineer away next?